Let's look at to the example here. Sketch piecewise defined function has determined domain and range. So what is the meaning of piecewise defined function when we have more than one equation in a function? So in this case, our function defined as gx. So we have more than one equation. We have a quadratic equation and we have also square root of x. So we have two equations here. So this is example of the piecewise defined function. So we can also have 3, 4. So that is as long as it is more than one equation. So that is referred to the piecewise defined function. So now, how can you sketch the graph of the function gx? At the end, the graph of the function gx will also, the graph of the function gx, you have to sketch on the same axis. Okay, so now how to sketch the graph? So first we have to look at to the function of x squared here. We have quadratic. In general, the quadratic graph, in general, this is how the quadratic graph looks like. So which is the domain should be from negative infinity until infinity. But now, since we want to have only x values less than 0, it's not include 0. Therefore, as you can see here, we have to put hole on the values of x is equivalent to 0 and we move to the left side. So we just interested to take the graph on the left hand side because we are referring to the domain given for that particular equation. So when your x is less than 0, so that's why the graph is only on the left side. So we will not show the graph on the right side because we just take on the x less than 0, meaning that x must be negative and on the values exactly 0, it must be whole. Then the next one for the second equation, which is square root of x. So we need to sketch the graph for the domain greater than equivalent to 0. So for this case, this is how the graph looks like. And for the values of 0, it should be dot. So when you try to combine between the first and the second equation, this is how the graph looks like. So even though on the first equation just now, our values on the x is equivalent to 0 is whole, when it is combined with dot, at the end, it will be dot here. So this is how the graph of the function gx looks like. So when you try to combine between that two equations, it will be something like this. And when you try to determine domain from this function gx, so what is the domain? So the domain of the function g is definitely from negative infinity until infinity. Why? Because for the domain, we have to look at from the left to the right. So we do have the values on the left on the negative values x and the values of x until infinity. So that's why the domain for the function g from negative infinity until infinity. And how about the range? So how to determine the domain, how to determine the range of the function g? So you have to look at from bottom to top. So the first values of y starting from 0 and it is dot here, therefore close bracket 0 until infinity. So that is how to determine domain and range graphically. Now let's look at to this example. We have the function f(x) is equivalent to modulus of x where x is less than 2 and 4 when your x is greater than equivalent to 2. So for the first graph here, this is referred to the function modulus of x. So if you try to draw the general or the basic graph for the function f(x) is equivalent to modulus of x, so this is how the basic graph looks like. So since we want to take only values when your x is less than 2, so we need to ignore the values greater than 2. So let's say this is 2, so we have to ignore this part. So that's why the graph will be like this. And on the values of exactly 2, it should be whole here. So this one is whole. Why? Because there is no equivalent sign on the domain given for the equation of the modulus of x. Therefore, you just have only this side and on the values of 2, so it should be whole. When you when you have the values of x is equivalent to 2, what should be the values of y when you substitute here? So the y is also equivalent to 2. So therefore, on the whole here, the point should be 2 and 2. And for the next one, for the constant function, so this is referred to the constant function, fx is equivalent to c. So we want to have, supposedly, your graph should look like this. On the line y, this is the line y is equivalent to 4. But we have to ignore on the values less than 2. So we have to erase this part. So we have to take the graph starting from x is equivalent to 2. So, and on the values of exactly 2, this one should be dot. So that's why, as you can see here, this is the graph referred to the second equation. This is dot until infinity. So the final graph will be like this. So this is your final graph. So what is important when you try to sketch the graph of piecewise different function is the point, let's say for this case, you don't have to, it's not necessary for you to put all the scale here. So what is important here, the values, for example, the values of 2, or you can just put the point here, 2, 2, and this one we know that is 0. And then another important point here is 2, 4. So it's enough for you to just put that point and make sure your graph is correct. So the rest of the values, -7, -6, all the scale here is not necessary for you to show. So the most important part, you show this point, 2, 2, or you can just put 2, 2, and then the values of, mark the values of y is equivalent to 4 here. Or I think it's better for you to just put the point so it is clear that you are referring to the values of 2, 4 here, and you are referring to the point of 2, 2 here. Okay, so let's look at to another example here. We have three equations in the function of f. So the first equation refers to the function, a constant function, y is equivalent to 5. And then the second one refers to the quadratic. And the next one is referred to the identity function. So if you try to sketch the graph separately for the function, so constant function is referred to this line. So this is when your y is equivalent to 5. But since we don't want to have the values greater than -2, so we have to erase this part. And we just have to mark the values of -2 here. And this one should be dot. So this one should be dot. So that's why you have the graph for the first equation here. Y is equivalent to 5. You need to mark the values of 5. So that is important point. Or you can just put in terms of points. So the point here is -2, 5. So this one should be dot because there is an equivalent sign. So that is for the first equation. Then for the next one, for the quadratic, by right, our basic graph for the quadratic should be something like this. And when you refer to the domain, we just want, or we just interested with the values of x between -2 until 2. And please take note whether is there an equivalent sign or not. So for this one, x squared here, so we have, this is, okay, this is referred to the -2. So we don't want to have the values less than that, and we don't want to have values greater than 2. So on the values of -2, this one should be dot. On the values of 2, this one should be whole. So at the end, you will get something like this. So this is the graph referred to the second equation. And then for the last equation, refer to the identity graph. So in general, the basic of identity graph should be like this. So every x and y values should be equal. So when we are interested to know the graph for x greater than equivalent to 2, so we will ignore on the less values of 2. So we will have the graph starting from x is equivalent to 2. Definitely on x is equivalent to 2, y is also equivalent to 2. So this is how the graph looks like. So when you combine everything, so you have to mark the important point as I mentioned just now. This one is 2, 2. This one is 2, 4. The coordinate here should be negative 2, 4, and this one should be negative 2, 5. Okay, so you can try out this exercise and also A until D. Okay, I just want you to take note that when the domain are given in terms of modulus like this, so let's say for the question part B, you are given the equation negative modulus of x plus 1 if your modulus of x, if your domain is less than equivalent to 2. So when you are referring to this one, you have to apply the properties of absolute values. So in general, when you have modulus of x is less than equivalent to c, so it is referring to the x is between negative c and c. Therefore, the domain for the second equation here is referred to the x greater than equivalent to negative 2, but it is less than equivalent to 2. So the same goes to this one. So it is referred to the domain of x greater than 2, greater than negative 2, and it should be less than 2. So whenever you get the question on the piecewise defined function and the domain given for that particular equation in terms of modulus, so it will be like this, or you have to refer to the properties of absolute values that we have learned in chapter 1. Okay, so I think that's all. So please write out all the question. So we'll discuss during class. Okay, thank you.